Hello, people. Hey, hackers. Hey, guys. I tried this stream last time. Alright, cool. I'm just testing everything. What's up, sister? Cool. So I tried this last time, but it didn't work out as well as I anticipated. There were a lot of issues, and it kept buffering. So we're going to try it again and hope it works out this time. So make sure everything's good. Cool. All right. Let me whip out OBS and let me show you the screen. Cool. So now we can whip out PowerShell. Setting up my VM. Nice. Cool. So we need a CD into our OneDrive, Documents, Code, Java, and we need to remake our directory because I think I just deleted all the progress we did last time. So make directory, and we'll call this Caesar Cipher. I'll explain what we're doing in 1 second. I'm just finishing setting up everything. Cool. So I just made a directory called Cipher Cipher and CD'd into it. So today we're doing some cryptography with Java. This was intended to be one of the projects for a class I'm taking, but I figured it would be kind of cool just to record and code with you guys. I think it takes a lot of time. Yeah, VMs be taking some time. Or just setting up an OS will be taking some time. Cool. So let's whip out OneNote and we'll make our roadmap because we need to plan what we're doing. I did a little bit of this last time too, but I wasn't able to completely explain everything for you guys. So that's what I'm going to do now. Cool. So today we'll be making the Caesar Cipher. And the Caesar Cipher is a symmetric. I cannot type to save my life. Encryption method that works by iterating through a set of data and shifting each index of each character by a set amount. All right, so this is the Caesar Cipher, right? It's just an encryption process or symmetric encryption process, and I'll explain what that is in a second, but it basically shifts each character in a set of data by its, it's a lot easier to show you how it works than it is to explain. But before I do that, I'm going to explain what a symmetric encryption process is. So it's an algorithmic ciphering process that uses the same key to encrypt and decrypt data. Now, both parties use the same key. All right. So as I'm writing this out, I'll kind of explain what the Caesar Cipher is, how it works, what it's doing, etc. So the Caesar Cipher was named after Julius Caesar, and he used this cipher as a way to encrypt messages to his soldiers or during times of war, etc. So the Caesar Cipher is just a symmetric encryption that uses that works by iterating through a set of data, and each index of each character within that data is shifted by a certain amount. Now that new index is made the new character. And I'll kind of show you guys how it works in a second so you guys can understand what I'm talking about. But this set amount I have at the end here, right here, this is the encryption key. And this is what actually allows the encryption to be the encryption. I also call it the shift key sometimes because it's a lot easier to say and it makes more sense. But that is the encryption key. So to give you guys an example, so that way you guys aren't completely confused, I'll use a shift key of 1. All right. So with standard plain text indexing, A, B, and C, right? That's the first 2 characters of the alphabet, and each of them have an index. 1, 2, 3. There you go. So each character in the alphabet has an index, right? A is 1, 2 is B, C is 3, D is 4, and Z is like 26, right? Now, with a ciphertext indexing, with using the shift key of 1, this would make B, C, D has the indexes of 1, 2, and 3, because each index was shifted over by 1. So 1 was shifted over to B, so B is now 1. 2 was shifted over to C, so C is now 2. And that's how the Caesar cipher works, right? So this shift key of 1 will change each character's index and replace it with its new index and the character that matches that index. So if we had the plain text and the plain text was just hello, the ciphertext, using that same shift key of 1, that would now be IFMMP, right? Because each character shifted by 1. Now that's the shift key, so we can make the shift key 2, and it would shift over by 2 characters. Shift key of 3, and it would shift over by 3 characters. So it would just keep accelerating, is that the right word? I don't know, it will keep changing or shifting or whatever depending on the shift key. Now, in order to make this work in Java, we gotta use some algorithms, right? So we have 2 algorithms. One is for encryption, and the other is for decryption. Right. We have the encryption method. Whoops. All right, so encryption. Now, encryption, the equation is C equals X plus N modulus 26. Now, modulus is just finding the remainder of a character or of an equation. So if you divide something, it will get the remainder rather than just dividing it and getting the exact answer. So C is equal to the character, X is equal to the index, and N is equal to the key. And this key that we were talking about right up here, that's the key. Cool, so that's encryption. Now decryption is basically the same exact thing, but instead of just decrypt, there you go. Yeah, so it's the same exact thing, but instead of addition, we'll be using subtraction because we have to remove characters rather than, or remove the indexes rather than adding indexes. So X plus N. Oh, sorry, I just said this. X minus N modulus 26. Now C is equal to the character again. I'm actually just going to copy and paste the rest of this. Copy, paste. All right, I don't know why this isn't pasting. I think my computer is tripping. Okay, I'll just type it out then. X equals index, and N is equal to the key. Character. All right, so that's it. We have the roadmap done. We know how to encrypt, decrypt, the whole nine. So this should be pretty straightforward. I guess now we can actually open up PowerShell and let's clear this terminal. Let's touch, oh, this isn't Linux. Echo some new files. We'll need to make a main.java file, and we'll need to make a cipher.java. Cool. So that should be it from this terminal, or not terminal, PowerShell. So let's code this directory. All right, so I don't know why this is so high. Let's bring that down. Yeah, don't show the welcome page on startup. So let's get into this main.java file. And this is where we can do some actual code. Let me make sure it's big enough for you guys to see. All right, let me make this font size 25. And then like zoom in a little bit. There you go. Whoa. All right, is that big enough for you guys? Let me know. All right, cool. So public class main. All right, now we can do our public static. Is the stream buffering again? It looks fine on my end, but if it is for you, let me know. Public static void main. Then we can do the string. What you call this? And then args. Never mind, it's gone. All right, cool. Yeah, because I ran a Ethernet cord or LAN through my router to my computer, so I don't have to worry about Wi-Fi connection anymore. So hopefully it's better, but if it keeps tripping up, let me know. All right. So now we need to import the scanner class because we're going to need to use it for user input. So import java.util.scanner. Whoa. Scanner. Isn't that how you do it? That's probably on your end. All right, that's cool. So we can do our scanner, we'll call it S object. And then we can do scanner S equals new scanner. And then the system in. I'll make a space. All right, so now we have our scanner object so we can get user input. So now it's time we get user input, and this will be our text that the user will input. Cool, so let's make a print statement. System.out.print, and we will have them enter some text. So enter text. All right. Now this string variable, we'll call it text, and this will get whatever text that they type in afterwards. So s.next, there you go. So now we need to get whatever option they choose. So user input, and this will be their option. So this will be another print statement, system.out.pl. Actually, I would think the ln is necessary. All right, so now we need to have them choose an option, whether they want to encrypt the code, decrypt the code, or brute force the code. I don't think I actually brought up how I want to be able to brute force like this project. So let me quickly actually go over that. So I talked about encryption right here. I talked about decryption, but brute forcing is a whole part of this project that I want to incorporate. So I feel like I should kind of go over it. So brute forcing is just iterating through a set of data and attempting to use each piece of that data to try to gain access into something. So because there are only 26 possible keys, because there's 26 indexes and 26 letters, we can brute force most data in 26 attempts. And this works even if the key is over 26. Now this works because of how the Caesar cipher works, right? It's shifting each key or shifting each index of each letter down the alphabet, right? So if it's a shift key of 1, it shifts by 1 index. But if it's a shift of like 25 or 26, like Z would be 1. A would be 26 and Z would be 1. And then, hold up. Yeah, okay. So it comes to a point where you shift it so much that the Z is going to eventually get to placement 1, and then 2, 3, 4, 5, 6, 7, 8, all the way to 26. And then it's going to go back to 1, and then back to 26, which is the original place, because there's only 26 indexes. So at the end of the day, there's only 26 possible, iterations that you can do. So that's how the brute forcing will work, basically. So I'm going to throw that back over here. And cool. So now we need to have them choose an option, right? Cool. So we're going to have a new line here, and then it will be option 1, which is to encrypt. Then we need to have option 2, which will be to decrypt. Then we'll have an option 3, which will be to brute force. And then we'll have an option 4, which is to exit the program. There you go. So those are their 4 options. Now we actually have to get the input from whatever option they choose. So we'll get an integer variable, and an integer variable will be called option. It'll be take the input of whatever integer that they type in next. There you go. So we have those 2 done. What's next? I guess we had to get we had to see whatever option they chose and run whatever option that they chose with the input that they've given us, right? So we need to make an encryption option, and this will be if option is equal to 1. Whoops. Then we can break. Cool. So cool. So that will be the decryption option. That will be the brute forcing. That will be exit. And then we need error detection. Cool. So that's the encryption option done. Then this will be decrypt. And this will be an else if option equals 2, then it will break. Oh, there's no loop this time, so I guess I don't need to break anything, because last time I tried to do a loop. But let's see, I don't think I need the loop, so we can just Oh, let me actually just break. And then, there you go. So we just removed all the occurrences of the word break. Now, if option equals 1, do this. Else if option equals 2, we'll decrypt it. All right, cool. So this will be our brute forcing option, brute force. And this will also have to be an else if. Now shift tab back. This will be our exit option, so they can exit the program. And this will be a number 4. This will be a number 3. And then this will, be the exception. And the exception is just the error detection, making sure that the code doesn't, crash if they type in something that's not an integer. So we can just do an else. Cool. So we'll do a system.out.pln. All right. So we'll just tell them that the input was not recognized. Try again. Cool. So that's the exception done. Then here we'll do a system.out.println, and this will just tell them that the program is exiting. So I might have to put this back into a loop, but as of right now, we won't worry about it too much. Delete that. Cool. So now we have options 1, 2, and 3. So how are we going to encrypt, decrypt the whole process? Well, that's what the Cipher.java is going to come in. So I guess we can start the Cipher.java. So let's import java.util.scanner. All right, now we can do a public class Cipher. All right, and then we can make our scanner object, right? So let me make some room in here. So scanner s object. I really have a dumb question. I always see people delete text without being in front of the text when you type in the bar. If I know what I mean. But if your type bar is before the text, how do you delete that? You can hit the delete key if it's before, like this. So I usually use the delete key, but that's how I typically do it. It's like right above the backspace typically. So scanner s object, what was I doing? Scanner s equals new scanner, and then system.in. Cool. So now we need to get, damn it, I'm done so much. Of course, man. Let me know if you have any other questions, but now we need to make instance variables. All right, so what instance variables do I need? We need a private string, and we'll call this text because that's going to be the text that we get inputted from the main code. Then we're also going to need the private integer, and this is going to be the option that the person chose, so we know whether to encrypt, decrypt, or brute force. We'll also need a private int, and we'll call this a shift key, because that's going to be the encryption key to encrypt or decrypt or brute force the code. I think that should be it for right now. And I realize I might have an error I need to deal with later, but we'll see how it works until we get there. So now we need to make the constructor. So public class, whoa, that's not right. Public cipher and string, and we'll call this init text, and we'll have our int, and this will be init option. Cool. So now we have our public cipher, and this is basically when we make an object of this class, this is what inputs or what attributes that we'll throw into the object. So this dot text will equal our init text, and then the this dot option equals the init option. Cool. Why is it? Oh, okay. I mistyped init. There you go. So now, how do we make our first part? So because the encryption process and decryption process are so similar, I'm going to make one method for it, and it's going to be called our translating method. So translating method. Cool. So public string, and we'll call this translator. Cool. Public string translator. So we're going to have to return something at the end of this, but we'll have to worry about that later. So user input, and this will be our shift key. So we'll system.out.print, and then we'll have to ask them to input their shift key. So enter shift key, and there you go. So that's how we get the shift key. So now we need to do this dot shift key will equal the s dot next int. There you go. Let me throw a new line into that. So this sets up output. So we'll have a string called output text. And this output text is basically what we're going to be building the decrypted or encrypted text onto. So now we need to start our ciphering process. Get some water. Check OBS, check the chat. Cool. So this is the ciphering process. So how are we going to do this? We need for character, and we'll call this character. In the text.to character array. Stay hydrated. Thank you, thank you. All right. So now we need to get the original index, and that will equal the character minus a. So for encryption, let me scroll down a little bit. And this is big enough for you guys, right? I can make the text bigger if you need me to, but I thought that should be good. Yeah, encryption. How am I doing? I'm doing good. I'm doing good. I haven't streamed in a little bit, so I'm happy to be back on here. I set up a cybersecurity lab earlier, so I have my server in here now. I have a Wi-Fi Pineapple Tetra. I have like my own like private network in here. It's kind of cool. I might make a video off of it, but I don't know. We'll see. It's not like, you know, the big YouTubers network setups and stuff, but how am I going to do this encryption? If this dot option is equal to 1, so if the character is not a space. So this is the error I was talking about earlier. Let's say if we have like a period. Hold on, my dog's barking. All right, y'all, I'm back. So I got groceries, but I have to put those away later because I'm streaming. Dog Cameo. I can bring my dog in here if you want. Stay hydrated. How you doing? Oh, you want the Tetra in the future? Yeah, the Tetra is pretty cool. Yeah, I can bring my dog in here. I'll get him. I'm gonna just mute, but I'm gonna keep my camera on. All right, let me. This is my dog. Pretty snazzy. Say hi, Ramses. Cool. Yeah, I'm gonna put them away. All right, back to the code. All right. So, what was I talking about? Error detection, right? So, there's a problem with this cipher because it relies on changing the indexes of characters, right? Like if we have our it relies on changing the characters of our indexes for the index of each character, right? It changes the index of each character, but if we hit like a period or like an exclamation point, there's no index of an exclamation point or a period or something. So we're going to have to figure that out. All right, so yeah, I'm gonna have to figure this out. This is the roadmap, by the way. Yeah, okay, we'll figure it out. Oh, what a cute dog. Yeah, thank you. Just the hacking lab. Yeah, it's not that hard. My server is like homemade. Like I have a laptop and I put Linux Mint on it. It's in shell mode and then just open SSH. Now I can back up files to it using SCP. I can SSH to it during CTFs. Like I'll run iteration on it, so I'm not like destroying my RAM. But yeah, lower the music a little bit. Cool. So this dot option equals 1. If character is not a space, then we need to get the shifted index or make a shifted index, right? So this right here is the equation I was talking about earlier. The original. That's really cool. Yeah, thank you. Yeah, the whole server. I'll show it to you. You know what? I'll make a video on it. It may not be super interesting, but I'll make a video on it. So this will be our original index. You have a lot of PCs. I do. I have a Windows computer. I have a Linux computer. I have the Linux Mint computer you see over there. And then I have an older Linux Mint computer under my bed, but I just don't use it, so it's just sitting under my bed collecting dust. Yeah. So this shifted index will equal the original index plus this shift key, and then we'll get the modulus of 26. Thanks, man. Super interesting. Of course. All right, so this is the equation I was talking about, literally. If we go back on the OneNote, where is it? The encryption process right here. It's just this, but in Java. So it's literally just math at this point. All right, so we'll make a character cipher text. Actually, we'll call this, I want to call it, actually, no, this is an encryption process, so we can call it cipher text. So character cipher text equals the character version of the letter A plus the shifted index. And then we need to output text plus equals the cipher text. And that should be it for that part. Then we can just else output text. I think maybe this else statement. Okay, so Okay, hold on. I need to think this out. Because I'm kind of worried about special characters. So then we can just do this. All right, let's make the actual code, and then I'll do all the, what you call it, error detection stuff. Cool. So this encryption process is done. This encryption process should work for the most part. Now we need to make the decryption process. So if this dot option is equal to 2, then we can decrypt it, right? So we can do if character, I did not spell that right, if character is not equal to a space, because it needs to be able to detect not just spaces but symbols as well. So I might make like a symbol array. No, that's going to take too long. I'll figure it out. I'll figure it out. So int shifted underscore index is equal to the original. What? No, the original index plus this dot. You have one PC? It's all right, man. I only had one PC for a while. I just kept asking my mom for more and more. And you got to save up for them and stuff, so, you know. But a cool computer to get would be like the Razer Blade. That's like my dream computer right there. I don't know if you guys seen it or not. But the newest Razer Blade computer just looks so nice. This dot shift key modulus 26. All right. So this right here, I keep putting the, all right. So this is the decryption equation that I showed you guys earlier, right? Right here. So this equation should just decrypt the Caesar cipher or the cipher text or the plain text, whatever we're doing. So now we can do character cipher text equals the character version of a plus the shifted index. Whoops. All right, so now we need to get the output text, or add this to the output text, and it would plus equal the character. Okay. Oh, that's not right. So let's do a plain text, because this is decryption, and then it will plus equal the plain text. All right, there you go. And then the else, we will output text plus equals character. And then the semicolon. All right, so now all we have to do is return the program. Is this the for loop right here? So we can just return the output text. And that should be it for the encryption decryption process. So let's try this. Let's make a new object, and we'll call this the cipher C. We'll call it C object. So cipher C equals new cipher. And oh, we're going to have to make this down the line. We'll have to make it like right here, because we'll need our text and our option, right? There you go. That's not right. There you go. Cipher C equals new cipher text option. Awesome. So this will now cipher by taking whatever option we choose, the encryption, decryption, and brute forcing, and then it will do whatever option on the text that we input. Now, I guess for if it's option 1, we can do C dot in dot translator, and then this would be. Do I have to print it out? Oh yeah, because it's a string, right? System dot out dot pln, and then just delete all this excess, and then C dot translator, and then like that. So option 1 and 2 are basically the same thing, so we can just do that. I could probably do if it's option 1 or 2 just to save space on code, but I'm lazy. And technically that would make it easier for myself, but again, I'm lazy. So that should work actually. So let's try running it. All right, so it said, I don't know, it looks kind of small on my end, but I'll just read it out. So it says enter text. So if we enter hello, it will ask us to choose an option. So let's say encrypt, decrypt, brute force, or exit. Let's try encrypting it with the shift key of 5, MJQQT. Awesome. So that works. Now let's try decrypting it. So enter text. Let's actually use the MJQQT. And let's try decrypting it with the same shift key of 5. And we get hello. Ah, cool. So that works. Now it's time for brute forcing, I guess. Yeah, so all we have to do now is the brute forcing option. And we should be done, I think. So that would be kind of cool. How are we going to do this brute forcing stuff? So I'm going to keep it in the same cipher area. I think I'm just going to make a new method in here. All right, yeah, we'll call this the brute forcing method. And then this will be translating method for encryption and decryption. Cool, so we're almost done. We just have to get this brute forcing in. All right, public string brute forcing. Actually, let's call it brute force. All right. I can tell I haven't coded in a while because I'm getting like half tired now. And if you saw like my earlier videos, I did like 50 hours of programming, 12 hours of programming. I just live streamed that. So yeah. Let me get some more water. Cool. How do you do this brute forcing method? Okay. Well, I guess we need to set up output like we did last time. So set the output. Then we can just do a string variable. 50? Yeah, I did a 50-hour programming challenge with my friend Jordan. We didn't do 50 hours straight, but it was like a 50-hour time limit. But I think overall the videos were like, I think I did 5 parts. Each video was like, I don't even remember. That was a while ago. I'll look after I finish coding this. string. We'll call this brute forced text. Damn. Yeah. Cool. So we have this. So this is the same thing as the output text we did earlier. It's just brute force text. So now we need to iterate each key, right? So for int shift equals 1, shift, was it less than or equal to, right? Shift the key is less than or equal to 26, because there's 26, I guess, characters, 26 letters. And then we can do a shift plus plus. Oh, there shouldn't be a space there. All right, so now we can, I guess we can just actually start the decryption process. So we can dec the string, because the output string needs to reset each time we use it, because if we don't, it's going to take each version of the decrypted text and then add it onto the text we already encrypted it. So the string's just going to get gradually larger and larger, and we don't want that to happen. So we're going to take our output text. So string output text equals an empty string. And all right, so now we can actually decrypt using each key. So for character in our text to character array, int original index will equal the character minus a. That is not an int. int, there you go. So int original index equals character minus a. Now we can just do if the character is not equal to a space, int the shifted index is equal to, so this part right here, because we're brute forcing, is basically the exact same thing as the decryption process right here. So I'm just copy and paste this, because we're just decrypting it. We're just changing the key each time we decrypt it. So there you go. So instead of this .shift key, however, we're going to use our shift variable, because that's just the iterated key. So this would be module 26, plain text, with character whatever, output text is this. All right, so now after we iterate through that, we need to add our brute forced, we need to add the output text to the brute force text, right? So we can say a shift of, we can do a plus sign, shift. So right now I'm just concatenating the output, I guess, colon \n, and then plus our output text, and then we can add some new lines after that, and then like that. All right, so this variable right here, or this brute force text, this is going to show what shift we're using. So a shift of 1, a shift of 2, a shift of 3, and then right below it show the decrypted version of that key. So now I guess we can just return the brute forced text and save the code. And I think we're done. Let me add it to the brute force option. So I guess this would be system.out.pln. And then in here, we're just going to do our c.brute force. And that should work. All right, so let's try it, I guess. Control F5. I want to make this bigger so you guys can actually see it, but I don't know how. I guess I could just do like 1, 2, 3. All right. That's kind of weirdly big, but we'll deal with it. So hypothetically speaking, right, we got this MJQQT, but we don't know what the shift key is, right? MJQQT. So let's brute force it. And option 5 is hello. Yeah, there you go. So that works. That's awesome. So you can see it's tried the shift of 1, shift of 2, shift of 3, shift of 4, shift of 5, which is hello. And this is all this other fancy stuff. I don't know how I got these random symbols. I think it's because of the... I guess it works though, right? Now let me... So I guess it works. That's cool. Is there anything else I need to do? Because I think I could end it here. So we got the brute forcing done. We got the encryption done. Decryption done. Oh yeah, symbols, right? So let's try that. So if we Control F5 this. All right, yeah. So let's enter, like if I put a period in it, hello period, and if I encrypt it with a shift key of 5, it said an input not recognized. And JQ2TM. All right, so now we have a problem, right? So I guess we could just tell people to not use symbols, but I want to see if there's a way. Because I made a Python version of this a while back. So let me open up a browser. Okay, open it the other tab, it's fine. So Java, see if character is in array. Okay. Lord, fine. I know this is going to be annoying, dude. So that's what Stack Overflow is saying. Let me see what this one for Geeks from Geeks is saying. Sorry, Geeks for Geeks. So array. Check if a value is present in the array. Check whether a certain element is present in the array or not in Java. Oh, so like key and value stuff. Yeah, but okay. See, this is why I like Python, because you can just do like if X in list, then whatever. But this. Let me go on exclamation point GitHub, and then we'll go on Cosmodium CS. Users. Did I spell that wrong? Cosmodium CS. There you go. Users, me, repositories. This is my GitHub, by the way, if you guys want to follow it. Link is in the description. Yeah, so I made a Python Caesar cipher. I updated the README logo, but I kept most of it the same. This version is a lot more advanced than this Java version I'm making. This Python version is really freaking advanced. It works through files rather than text. So it'll like decrypt entire files and stuff, which is pretty cool. But I just need to see the Python file. Okay, see, that's what I did. Like, I had a list of symbols, and then it would detect if the symbol was in the code, it would just ignore it. So I might cop this. It's my code, so it's not stealing. All right, let me make like in a symbols array. How do you make arrays again? Bro, I haven't worked in Java in so long, dude. It's like because my GitHub's open, I may as well just go on like profiler, which is right here. This whole thing was just arrays. So source Java. Oh yeah, so it's like string first name. Gotcha. All right. So because these are characters, can I do like a char and then symbol equals this? All right, I'm skipping that one. All right, Control H will replace all of these with all of these. I don't know if I used any others throughout the rest of the code, so I'm gonna just hold down the Enter key. Cool, yeah, see, like that. All right. So now we can just throw this in here. All right, hopefully that isn't too much of an error. Why is it glitching out here? Oh, yeah, I forgot this is Java and not Python. So here we can do all right, how did I do this? Yes, the double quote that's confusing it. Ah, dude. I don't want to do this anymore. All right, so let me just comment this out. And let me go back on Firefox and see. Let me just incorporate this. So for a character in a character array, if C is equal to Q, contains true. All right, so we're going to try to incorporate something like this into my VS Code. So we'll try it on the encryption process. Now, I think the code's going to get kind of lousy from here, but it's all good. Cool. So character array, let me guess the character array. All right, so let's take, let me call this symbol. Symbols equals, and this will be a string variable. So string symbols will equal, all right, I think I can do everything but the backslash and then the backslash t. So we can do a space, then I'll just do, geez, this is gonna be annoying, dude. So space, I'm gonna just start from the top of the keyboard and go down because this is gonna take too long. Zero 987654321. All right, and then we'll need these three. We'll need I'll need to do a backslash because it'll see it as an escape sequence. Why is that not being seen as an escape sequence? Oh, okay. And then we'll need these two. Whoops. Oh, do I have to do like a backslash? There you go. Okay. And I think that should be it. Oh no, we still need the greater than, less than, comma, period, question mark, and slash. And throw that out here and delete that. Cool. So those are all the symbols that our code can't detect, I believe. So now we just had to take the symbols dot to character array, and if C, okay, so now we just say if character, so if our character is equal to C. Oh, didn't I use C for something? Oh no, that's in the other code, so we're fine. So if character is equal to C, okay. So this says if option is equal 1, if this character is in a space. Rather, if this character is in a space, if this character, I need to look this out, dude. This is taking a lot of work, a lot of brain power. The crazy thing is that I said I was almost done. And now I'm doing this. Cool. So let me think. Where's the code I'm working on? So Boolean contains equals false. So if the character is in the symbols, so if the character is a symbol, then we can just output text plus equals character. So instead of an else, we can do, so if it's not a space, it will do it with a character. So if it's not equal, So if the character, let me see what happens if I just run this. I don't think this is going to work, but I want to just try to run it. So enter text, we'll do hello, period. We'll try to encrypt it with a shift key of 5. Yep, and that did not work the way it was supposed to. Okay. Oh, it's doing hello after each character. Okay. So if it contains, then you can just output that text to character. So if Boolean contains equals false, for character C equals symbols. If the character is equal to C, contains equals true, break. All right. If I can't get this to work, I'll just release this version that you can't use symbols in. But the Python version on my GitHub does use symbol detection. So if you guys want to use that version, you can. This is more of a proof of concept, I guess. So if the character is not a space, or it's not, or if it's or if contains is equal to false, then it will do this. So we'll have to put this into here. So for character is C, if character so contains equals true. Okay, so now I just have to basically cut this out and put it like right here. So for character, all right, yeah, now this basically is just going to be shifted over by 1. Cool. So Boolean contains equals false. So for character C in the symbols, if the character is the same as C, it will continue. So this if statement has to be shifted over like that. And this is for that for loop. Okay. So if character C, if it's true. So if this option equals 1, character is not equal to space, or not the if, or if the contains equals false, it will do this, else output plus equals character. Oh, I guess it should be an and or an or. Oh, okay. I guess technically I could just, if the contains is equal to false, it will do this, else it will do. So if no symbols were detected, it will type out, it will encrypt the character, else it will just plus equal that character. All right, so let's try this. I keep doing that. Control F5. All right, so this should probably work. So we'll do hello. Whoops. So right here, we'll do hello. And then option 1. Oh, damn. we have one of, I think we're missing the semicolon. I mean, curly brace. No, that's not right. All right, what is this one for? Oh, I think that's for the class. So this has a curly brace, that has a curly brace, that has a curly brace, so that's fine. Oh, is this just an extra one right here? So what's the for loop end? Got you, okay. So this curly brace can go here, and then this curly brace can go down here. Yeah, I hate when this happens. This will be taking so long to fix, dude. All right, so this is for this. Then this for loop one needs one right here. Is that better? So for... Oh, I think one of these need to be gone. Does that fix it? So this is for this is for this, that is for that one. So this is fine. Then this is for this one, this is for this one. This for loop goes down to here, so that's that one. Oh, it's because it closes off, right? So for this for loop needs to end down here. There you go. So let's save this. Control F5. This is why I use Python. This is why I use Python. All right, so let's try and encrypt it. Hello, period. Okay. Oh, did I try running the wrong file maybe? Hello, period. 1 is encrypt. Shift key of 3. Oh, wait, it worked. Right? Oh, whoops. If I Control F5, I think that worked. So, hello, period, encrypt with a shift key of 5. So it's just saying the input not recognizing for no reason. Where does it say that? In here. So it's just saying that for no reason. So we can fix that. So now if we try to incorporate this into the decryption, okay, I think we're almost done. So where's the encryption process? So we're literally just going to have to copy this. That's weird, dude. All right, so let's copy this. And then in here, we can just paste all that in here. Now we're going to have to do some tweaking. So there should be 2 under here. Or does that still work? Like if I save that? Where's that error? Duplicate variable. Okay. All right. So that should be it, right? So if I Control F5, all I have to do is type in hello, period. Then we can encrypt it, shift key of 5. So MJQQT, period. So it still works. Now if we try to do this again, so let's do MJQQT, period. Then 2 to decrypt it. And then shift key of 5, hello, and then it does a square bracket. We're getting closer. We're getting closer. So in the ciphertext, can we do like if it's not equal to a letter? Let's try that. I think that would be a lot simpler, right? Like if it's a letter. Okay, yeah, that's what I'm going to do. That's what I'm going to do. That's going to be a lot easier. So Java if character not equal to letter. I feel like that could save us a lot of time. Okay. So if it's an alphabet, okay, this is perfect. So if the character is in the alphabet, it will encrypt it, and if it's not, it will decrypt it. So we can get rid of this. Shift tab. So if contains so instead of doing this, we can say if is in alphabet. So we can just take this, throw one of these out here, and delete this. So if okay, character C equals an S. Oh, so instead of C, so if character, whoops, no. So character, and character. Whoops. All right, so if the character is in the alphabet, it will do this, else it will just plus equals it to the encryption process. So let's try encrypting this again. So we can say hello with the exclamation point, then encrypt, and that didn't work. Unresolved variable. Oh, it's because the decryption process is still doing that. So let's close this down. And for, I think this is fine, actually. If encryption, if decryption. All right, there you go. So let's try this again. I keep doing that. Control F5. So if we enter a hello with an exclamation point, 1 to encrypt it, a shift key of 5, MJQT, exclamation point. Awesome. So let's try to decrypt it. So enter text MJQQT, exclamation point. Then we can hit 2, shift key of 5, hello, and then it has the letter P. Okay, so now we just need to incorporate this for the decryption process. So if it's going to copy this line right here. So if the character is in the alphabet, it will do this, and else it would just add the character on. So, okay, let's Control F5. So enter text, hello, exclamation point, option 1, shift key of 5, and it encrypts it. So if we run the same thing again, MJQQT, exclamation point, and we try to decrypt it with the shift key of 5. Yes, dude. Oh, that took way too long. That made this video an extra half hour long. Okay. It works. So the only problem is this input not recognized. Okay, so I guess we're pretty much done. The only thing we need to fix is this exception. So why is it printing this out? Because it recognizes the input. So what happens if I put the while true in here to make it loop? So while true. Good job, thank you. Yeah. That took way too long. But I guess it's better that I did the extra step, because if I didn't, it wouldn't be as efficient as it could be. So let's just add a break statement after each of these. All right, so after here, whoa. And then else break. So let's see how well this works now. All right, so quick test, hello, exclamation point. Let's try encrypting it. And enter shift key, we'll do 5 like we've been doing. Okay, that works. Oh, that's sweet. So let me clean up the code a little bit. So after the option where it gives you the list of options, we can do a, whoa. We can do, after the 2 open lines, we can do option. So that way it looks like you're entering your option. And after it tells you to choose an option, I want there to be a new line right here. And then that will be it, actually. So let's try running this code, making sure everything works. All right, I'm going to try and make it a little bit bigger so you guys can see it. All right, so at the bottom here, it says enter text. So I guess we can type in hello, comma, world, exclamation point. Exception thread. Input match. Did I do something by accident? Oh, I think I just hit enter or something. Okay, I think that was just the IDE, because that was really weird. So, hello, world? Okay. Why is it doing that? Or maybe it's the while loop. Maybe it's the while loop. Okay, let me zoom out of here. Whoops. It's always like a 2 steps forward, 1 step back type of thing. But I'm almost done, because the only thing we need to do is fix this error. Maybe the space. Oh, did I incorporate space into symbols? I think I did, like with this part. But you still could be right. So I could end up, or is it it could be brute forcing too, because I haven't incorporated this into brute forcing, I guess. But you might be right, sis. Or sister. All right, so let's get rid of this if statement. Replace it with this one. So we'll control F5. The term. Oh, yeah, I threw all that stuff in the front. Terminate job, yes. There you go. Okay. So enter our text. We'll do hello, exclamation point. If I try to encrypt it, let's just keep 5. That works. Okay. So let's try to decrypt it. Oh, I just made my text number 2. Yes. Clear. So let's try this again. Enter text. Isn't it like MJQQT, exclamation point? Let's try to decrypt it. Shift key of 5. Hello. Okay. So then let's try this again. And we'll do MJQQT, exclamation point. 3 for the brute force. And option 5 is hello. Okay. And the exit option should work too, right? Like if I just type in some BS, hit 4, exiting. Awesome. So what happens if I type in some random stuff like this? And then hit encrypt. So key of 6. Okay. So it keeps the numbers. It doesn't affect the numbers. All right, I think we're done. That's it. Cool. So I'll show you guys the full. I'll run over the code real quick, and then I'll run it with you guys, and then we can turn off the stream because this is fine. Cool. So at the beginning of the video, I talked about the Caesar cipher, how it works, how the process works, the encryption process, what it originates from, the algorithms for encryption, decryption, and brute forcing. So basically, an important thing about programming is to do roadmaps like this beforehand, because if I didn't do the research to figure out like the algorithms or the equations to do the Caesar cipher, this project would have taken way longer, right? I would have been Googling and Googling and Googling, and that would have not been entertaining for you guys. I was able to efficiently just incorporate this equation literally like right here. Hold up. Right here. This is the equation. It's the same thing, just with variables. So it's all math. It's all algorithmic processing and stuff. So in the main code, we have this while loop, so that way we don't have that annoying pop-up of this after each time we run it. It just enters text, right, and it saves it to a text variable. Then it'll allow you to choose an option, and let's say you encrypt, decrypt, whatever, and that option is an integer, and depending on what number you put in, it will choose the option you chose, right, through this Cipher object that we made. And the Cipher object that we made right here, or the Cipher class that we made, basically just encrypts, decrypts, or brute forces depending on the option you chose. Right, so we have the symbols. I think I should make this a private string because private string. So now, where did I use the symbol detection? So encryption. Where is the symbol detection? What's the point of the symbols thing if I don't? Control F sim. Oh, that's right. I don't need this anymore because I just said if it was in the yeah, so I can get rid of that. Cool. So yeah, we make the constructor so that way we can make it into an object, right? So get the init text, the init object option, which is literally what we're doing here, the text and the option. Then we get the shift key from them. This is the translated method, so we can encrypt and decrypt. We'll get the shift key, so we can use the shift key to encrypt or decrypt depending on whatever option they choose. And then we have a Bruteforcing method, which basically is just a more profound version of this decryption area, or this decryption method. And that's it. So I'm going to save this, and then we can run it, and then I can leave. So let's control F5 this. All right, let me control C. Yes, clear. All right, so let me make this bigger. Control Z. Cool. All right, so enter text. We'll do subscribe to Cosmodium. Exclamation point, exclamation point. And whatever region. So what you were saying about the space could possibly be right. So I might do an... So if it's characters not in character in the alphabet, so it shouldn't matter though. Because if it's not a character in the alphabet, then it doesn't matter. So if it's in the alphabet, it'll do this. Otherwise, it'll add the space. Or is it just being weird? Hello, exclamation point. Hello, world. You're right, it's the space. It's the space. All right, so I'll just have to do an else if right here. So else if character is equal to a space. We can just do output text plus equals a space. The little smiley face. All right, cool. So we can just replace the bottom two parts with this. So all right, awesome. So hopefully that will detect the errors now. So if we run this again, so let's see, hello space world. There's still an error, but it only happens with a space. Like if we just do hello, there's nothing there. So why is the space being so weird? Maybe we could. Okay, I need to think this out, bro. Let me get some more water. All right, maybe I'm going to take the so this equation or this detection, whatever you call it. Whoops. So let's take this if statement. Cool. So if this, what if I do that? And then this. Cool. So we're just going to take this and, oh no, I can't just do it like that. I just need to take this part because it uses different variables. Is that part of it? Did I change the variable? No. And shift, and then this dot shift key. Yeah, so let's put this under here. All right, so let me save. Okay, so if it's a space, it will do this. If it's a character, it will do this. Otherwise, it will just add the character. Same thing here. All right, so this should be fine, right? Control F5. Did it run? Okay, you know what? Clear. So enter text, we can do hello, space, world. Bro, I swear. Can you do exception detection or whatever? Exception in thread main. All right, I'm gonna Google this error. Bro, I'm supposed to be done by now. The code works. It's just this one space that's just throwing it off. Stack Overflow, please come to the rescue. Accept all cookies. My cookies delete automatically. Okay. So should I be using input.next line? Is that what it is? Okay. So Control H will find every use of s.next and replace it with s.next line. That's right. And replace it with x line. All right, I think that's right. So I'm gonna just, and then same thing in Cipher. Oh yeah, this only gets an integer values for these. All right, so let's see if this works. Always keep doing that. Control F5. All right, hello space. All right, whatever, blah, blah, blah. Yes, dude, okay. Okay. All right, I think we're done, but now the code is messy, and I don't want to mess with it too much because it's just going to error again or something. But it's good coding practice, so. All right. So I guess we don't need this. Let me get rid of this and just see what happens. And then get rid of this. So let's see if I save this. I keep doing that. I swear, the day I don't just open up all my tabs or all my windows or whatever you call it. So if I do hello. Yeah, all right, cool. The code works now. So let's just throw some comments in here and call it a day. All right, so we'll start with the main code. Anything else I need to do in here? Because this should be pretty straightforward. All right, so the main code is fine. The class, instance variables, constructor, da da da, blah blah blah. Encryption. If character is in the alphabet, it will do this. Exception. There you go. Oh no, I hate this one. All right, so now we can copy this, throw this in here, move this back, and then we can just type in exception. All right, then this is the last one right here. And then / exception. All right, boys, we're done. You're gonna go, man? Have a nice day. You too, man. I just finished, which is lucky for you. Cool. All right, so we're done. Let me just run the code and head out of here. All right, so let's run this. So if we run the text, we can do hello. No, we'll do, I want you guys to see this, so I'll make it bigger. There you go. So subscribe to Cosmodium. CS, exclamation point. No errors. We should look at that. So if we encrypt this message and then use the shift key of 5, there you go. The message is encrypted. So let's copy that message. And if we run the code again, enter text, we can enter this text right here, decrypt it with the shift key of 5, and subscribe to, okay, we're going to ignore that. Why is it doing that now? All right, good job. Thank you, man. I appreciate it. I'm going to just keep tweaking this until it doesn't. So it seems like there's an error with the decryption process now. You know, if I got $1 for every time I said I just finished throughout the stream. Let me see. So Cipher, Decryption, if character is in the alphabet. Plain text. For character into text array. That's weird. Let me do a control. Did I not run the control F5? All right, enter text. So we can do our, this right here, decrypt, shift key of 5. So instead of Cosmodium CS, it made the C's into these like square brackets. Huh, that's so weird. So if we go into our main, so if option equals 1, it does this, if option equals 2. And when we did this with the Cosmodium CS, it receives, yeah. Oh, is it because they're capital? But it's still got the S for subscribe. That's so weird. So the plain text and the Cipher text are the same variable, output, whatever. Huh. Cool. Let me plug this in. Sorry. All right, guys. So I don't know why that's tripping up so much. So it looks like it has to do with the decryption. So if the character is in the alphabet, it will do this. Plain text equals A plus shift key, output text plus equals plain text. And then what if I ran the code again? And we just did subscribe to Cosmodium without the exclamation points. Encrypt it with a shift key of 5, and we get that. So if I do the same thing and as decrypt it with a shift key of 5, it still makes the C's into these weird square brackets. Huh. So is that with all letters? What if I do A, B, C? Oh, whoops. So if we made our text all caps, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And if we encrypt that with a shift key of 5, interesting. So a capital A becomes like, so what happens if we do this with lowercase letters? C, D, E, F, G, H, I, J, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And if we encrypt it with the shift key of 5, so that's fine. So I guess it's just a problem when it comes to uppercase letters. So what happens if I change the code and make this A like a capital? And then made this A a capital. Does it affect how the code is run? So enter text, we can take in, all right, so let's do our A, B, C, D, E, F, G, H, I, J, K, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And if we encrypt and we use an option of 1 to encrypt, yeah, okay, that's not good. So let's go back here. So it seems like there's a problem with capital letters. So we can do like an if the character is a capital letter, we'll make it the lowercase version, decrypt it, and make it a capital letter again. So let's do that. So if the character is in the alphabet, whoops. So if the character is in the alphabet, if character dot is uppercase. Oh my gosh, dude. Is upper case, right? Is that how you do it? All right, this was just helping me out. So if character dot is upper case. I hope that's right. Yeah. All right, so what's wrong with this? Oh, so if the string version of character Okay, so we need to find a way how to make a character a string. So for character, let's say, oh, did I close Firefox? Okay. Java make character into string. Please be simple, like one-liner. Okay, so it's dot value of. Gotcha, string dot value of. So we'll call this string case checker equals the string dot value of character. There you go. So if case, so we'll just call it letter, string letter. So if letter is an uppercase letter, what's there? Method of the case is undefined for the type string. Is it uppercase? Jesus, what's the uppercase name for Java? Java is upper. All right, sorry. Java is uppercase. This is right. Oh, okay, so you have to put stuff in it. So if letter dot is uppercase, what? Like, that's really weird. Hold on. So print character that is uppercase. So I just want to see if the character is an uppercase letter. So if character dot is uppercase letter, is that right? Like that. Okay, Java detect if letter is uppercase, because y'all are giving me too much trouble. How to find uppercase letters in a string. Actually, no, I want to use this one. All right, so holy mackerel, dude. I just want to see if a character is uppercase or not. Isn't there like an is upper like method or not method? I think method, yeah. Character. Check whether a given alphabet is uppercase or lowercase. Thank you. Please just be very straightforward and simple. Okay. So if character and character Z. So if system.out.print ln. Wait, isn't that what I did for... Hold on, let me put my browser on the side real quick. Because this right here, less than equal to... If this is true, it's a capital character. But I did this for this right here, right? So if I do this, if character is less than the capital A, and character is less than or equal to capital Z. Okay, so what I can do is actually, instead of all of this stuff, we can take this out. So if it's a lowercase letter, it will do this code. Okay, so if it's a lowercase letter, then it can, we can just get rid of this. Whoa. Get rid of this. Get rid of this. So if character is less than or equal to this, we'll do this. So now we can throw this in. If the character, is lowercase, and now we can do this, and we can do if character is uppercase. All right, now we literally can just copy and paste this, but we just need to convert the uppercase letter to a lowercase letter, then reconvert the lowercase letter back to an uppercase letter after we do the conversion. So we can just do a string lower equals the string dot value of the character. There you go. So now we made the string into a letter. Now we need to make that letter into a lowercase letter. So we can do letter, then string lowercase equals letter dot lower to lowercase. Then shifted index. Okay, so if the character is an uppercase letter, we make the character into a lowercase letter. But how do we get the index of the character? Like how are we doing? Oh, see this right here. So int original index equals the character minus a. So let's cut this out, and let's throw this into here. Oh, wait, actually no, we can leave that up here, and instead we can change the value of the original index. So the original index will now use the lowercase letter so if we do character lowercase letter and give it the value of, you do char to value of lowercase. Does that work? No, okay. How do you make a string into a character? Convert string into a character. Character equals, okay, so char at turns a single character of a specific index. Okay, I need like, yeah, that's not going to completely work for me. We need to find ways to convert a string into a character. Because right now, for this, we see if the character is an uppercase letter, we make the letter a string so we can get the lowercase version of it. Then we need to make it back into a character so we can change the index. Now we need to take the string and make it an index. How do we do this? Convert string to a character. Character my string. Character my char equals my string 6. Okay, I need it. Can we just try the char at then? We'll see how that works. All right, so character lowercase equals char at lowercase. That's what it was, right? The chr at. That's what I did. This is just annoying. How long are we in? Just 2 hours, 11 minutes? All right, I'm gonna try to go for finishing this in the next 20 minutes because this shouldn't be taking this long. Char c equals s dot char at. Okay. So original index equals, so this lowercase letter right here. So lowercase letter equals lowercase dot char at and then 0. And then we can take this lowercase underscore letter. And then the cipher text equals the character plus a shifted index. Now this cipher text, so string cipher text upper will equal the cipher text as a string. So how do we make a character a string again? A character into a string. String equals, so this equals the string dot value of the cipher text. There you go. So now we can just do cipher text plus equals cipher text upper. And that should be it for the encryption process. So let me see if it keeps its formatting. So if we do Control F5, we can do hello like that. And if we encrypt it, Shift key 5. Oh my God, dude. So if this needs to be else if maybe. Hello, 1, 5. Okay, so it encrypts it, but the M is still lowercase. Oh, so we didn't make it back into uppercase, right? So cipher text, output text plus equals cipher text to upper. And then we can do cipher text upper equals cipher text upper dot to upper case. There you go. So let's try this again. So if we do hello, option 1, 55, that should have worked. Maybe I need to recompile it. So enter text, capital hello, encrypt it, shift key 5. Yes, dude. Yes. Okay, so it keeps the uppercase letter. All right, so now we just have to make this easier to read. So convert to lowercase for ciphering. Generate new index. And then this will actually decrypt it right here. And then we'll convert the output back into convert back to uppercase. There you go. And this is the encryption. Algorithm. There you go. That's the entire thing done. So now we just have to make this work for the decryption process. So I can just copy this. Actually, I need to copy it from this part all the way to here. So now we can do this. Now instead of this will be for decryption. And then this shifted index, this will have to be a minus. And that's it. So for the brute forcing, I guess all right, we're gonna have to take this if statement and replace it with, yeah. So replace these. All right, and save it. Guys, I think we are finally done. Oh, man. All right, Control F5. Cool, let's do this. Let's do the whole. All right, let me clear this. Oh, whoops. Yes, clear. All right, so let's run the code. So let's try our subscribe to Cosmodium CS and then 3 exclamation points. So let's try to encrypt it. I swear, dude. Okay. Oh, there's a missing semicolon, curly brace. Where did I forget to put this curly brace? It's in the cipher, obviously. Oh, is it in the brute forcing? So this is for the else statement. This is for the else if statement. This is for the if statement. Oh, this is weirdly shifted. All right, hold up. Why is it so offset? There you go, like that. Then this if statement goes in here, and that should go in here like this. Oops. So now this else if statement, I'm just pushing it all back. There you go. So that looks better. And then this else statement is also kind of broken. So this for loop, then it'll do this for loop, then the if, the else if, and the else. All right, so what's this one for? Let me just go slowly back. So this is for that else statement. This one needs to be for this for loop. So that's for this for loop. Then we return it. So we do this else statement. Then this brute force thing needs to be like out here, I think. Then there's this one right here. And that's what this is for. Okay. That looks right. All right. I want to jinx it and say we're finally done, but let me just try to get this all ran in anyways. Oh, wow, that's a lot closer than I had it last time. Okay. So let's clear the terminal. So if we, clear the terminal. So let's run our code. So subscribe and like. Then we can encrypt it. Shift key of 5. And there you go. So it encrypts it fine. Now we can run the code again. Let's put our code text in here, and we can decrypt it with the shift key of 5. And that why is it doing that? I don't think I've ever had so many bugs and stuff with a project before. Ah, man. Cool. All right, my goal is to do this in under 3 hours. We have half an hour. All right, and I just want to get this done. So in order to do that, we got to figure out this error right here. I'm going to try to run it again, just see if it was just like something with the compiling. So we'll just do hello in all caps. Hello. We will encrypt it, shift key of 1. So it should be G. Okay, so that's the problem. With a shift key of 1, it should be H. Oh no, that's right. HI and then EI. Or EF, G. Okay, no, that's right. So the encryption works. So if we decrypt so enter text, if we decrypt this with a shift key of 1, it's hello. So that works. What happens if we put some text in there? So if we put like an exclamation point, whoops. Yes, let's clear this. So if we put an exclamation point in here, so let's hello, exclamation point, encrypt with the shift key of 1, IFF IFMMP exclamation point. That works. So if we try to decrypt it, IFMMP exclamation point, and then decrypt with the shift key of 1. Is it decrypting it again? Oh, maybe the decryption. No. All right, so oh my gosh. Okay. How are we going to do this? If characters less than or equal to A and characters greater than Z. Okay, so if it's that, so if it's an uppercase character, it will convert the character to a lowercase letter, and then it will make the, have it print this out. Maybe, is this the error right here? The character at 0? Well, no, that should be fine because that's the character itself. All right, let me run this. So enter text, hello, exclamation point, 1, shift key of 1. All right, enter text IFMMP, exclamation point, option 2, shift key of 1. IFMMP. That's 1, 2, 3, 4, 5 letters. 1, 2, 3, 4. Oh, so the I is what printed out, right? Yeah, so what printed out was H, G, N, and Q. So it added one. It encrypted it. Yeah, so it's encrypted. The decryption process is encrypting it. Why is it doing that? We have the minus right here. Oh, is it not looping, or is it? If we print ln, this is in a for loop, right? So for each each character in the text, it will okay. My question is, why is the decryption process encrypting it? So this, why is this letter, why is the R blue? Lowercase letter. All right. So the original index. So it equals the lowercase letter minus A. int shifted index, original index minus this dot shift key modulus 26. Oh my gosh, dude. See, this is what's confusing me. It's like the encryption process is doing exactly what it's supposed to do. Unless the original index is different. So let me see the original index. The original index is an int, and it takes the character, which is a character, minus a. So this decryption, it's an int original index. Then it takes our lowercase character minus a. Well, if this is doing the same thing as the thing above it, right? So if character is I need to think this out, right? Because this is the same thing. Once we convert it to a lowercase character, it's doing this process right here. So int shifted index, then the character cipher text equals character a shifted index, and then output it plus equals. Equals the cipher text upper. So we need a plain text because this is the decryption process. So plain text, here's the plain text upper, and it's the string value of our plain text. Then our cipher text, so plain. I'm gonna just make this a new variable called string called plain text output is equal to our plain text upper to uppercase, and then we'll call this plain text output, and that's what will be outputted. So the encryption process works. The decryption process is very questionable right now. Like if I do IFMMQ, I believe, and try to decrypt it with a shift key of 1. So what comes after I? H-I-J. So it does the capital letter. Why is the lowercase letters not working now? Oh, is it the original index? I think I need to redefine it. So original index is equal to this. All right, so I just need to find the right place to put this. Where did I put it in here? So original index, I do it after the int shifted index. So I can do it right here. And then in the capital letters. So I can just do it like that. Let's try this. So IFMMQ, I think. Oh, IMFMP, exclamation point. Let's try to decrypt it with a shift key of 1. Okay, so it's still increasing each character by 1, except for the H. So it seems like the capital letter is working better than the lowercase letter. So equals the character minus A. Then it... Oh my gosh, dude. I found it. This one little plus sign right here has been tripping up my code for the past like 30 minutes, dude. This is why nobody likes programming. Now I just put that minus there. And by the power, watch this work, watch it work. IFMMP, decrypt, shift key of what, 1? Okay, now it's still not working, but I fixed that. Hold on, I need to recompile. Oh, I didn't save it. Okay, that's what happened. So now I can control F5 it. Alright, control C, terminate job, yes, clear the code, run this, IFMMP, exclamation point. Let's decrypt it, shift key of 1. It says hello. Dude, it's the most rewarding feeling and the most frustrating feeling when you find bugs or errors like these. So now it works, right? Can I just do hello world, exclamation point. If I encrypt it, shift key of 5. All right, we'll copy this. Now if I try to decrypt this, decrypt, shift key of 5. And now the H is tripping up again, dude. Are you serious? I mean, the W is tripping up. All right, so we're almost done. Maybe there's something else in here that I'm not paying attention to. All right. So it seems like something with the spaces again. So I can do like if character is equal to space, and then we can just do output text plus equals a space, and then save it. Let's see if this will work. So enter text, and then decrypt, shift of 5, I think. Is that a double space? Oh. Else if. Oh, whoops. This decrypt, shift key of 5. Okay, so it all works except for this capital W, and it seems like it happens after a space. So if I do like so if I do like I don't know, like the video, will the text after the spaces be messed up? One is encrypt. We'll just use a shift key of 1 to make this easier. So if I run this code again, we'll enter this text, we'll decrypt it with a shift key of 1, but it works fine. So is it with capital letters after spaces? So if enter the text, if we do like, I realize you guys like can't see what I'm doing, so I'm gonna just make this bigger. Hopefully that's a little bit easier to see. So if we do like the video, will those capital letters be messed up? So encrypt, shift key of 1, this, there you go. So I'm glad the encryption process at least works. Enter text, we can decrypt it, and shift key of 1, like the video. Okay, so what if we throw a symbol in here? This, exclamation point. Whoops. Yes, clear. This, part this, exclamation point. So now if we do decrypt with a shift key of 1, like the video. So does it work now? Is it working? If I do subscribe to Cosmodium CS, exclamation point. If I encrypt it with the shift key of 1, now we can decrypt it. To decrypt, enter a shift key of 1. Yes, dude. Yes, it works. I don't know how it just started magically working, but it is working. So it works. Let me just clean up the code and get out of here. Okay. So I guess I'm gonna just leave this space thing here. So yeah, we're gonna throw this in here. Cool. So this will be on my GitHub if you guys are interested in, seeing the code. I do have a more advanced version on this on my GitHub page if you want to check it out. Let me show you. Yes, sir, right? Yeah, thank you. Cool. So this is if character is a space. So the last thing we need to do is also make sure this works on the Bruteforcing. Is a space. And then this is uppercase. This is the decryption algorithm. Generate new index, right? So right here, so we can enter here, and then cool. I think this is done. So now we can just literally copy and paste our decryption code and put it in our Bruteforcing code. So we can replace all this with that. Yeah, all right, cool. So because we make our own yeah, we can just do this because the original index is changed in here. Yeah, we don't use the original index here. So the original index is changed in here, and the original index is changed in here. All right. So let's make sure the brute forcing works now. And then we're done. All right, so Control Shift plus, make it a little bit bigger for you guys. Control C, yes, we'll clear it. All right, so let's try to brute force my text. Oh, whoops, I tried to copy, whoops. I copied my clipboard from the thing, from the, oh my gosh, all right, just Control F5. Yeah, clear. Control F5. Okay, let's try this again. Enter text. We do hello, exclamation point, encrypt it with a shift key of 1. IFMMP. Oh yeah, that's right. So we can enter IFMMP, exclamation point. We can decrypt it. Enter a shift key of 1. Oh, actually, well, yeah, and that'll be hello. Now let's try the brute forcing. So IFMMP, exclamation point. And if we brute force it, no, dude, the brute forcing's not working anymore. I know why it's not working anymore. All right, so let's close this. So for the first shift key of 1, the output text is an empty string. Okay. Why is this not working anymore? Well, actually, no, I'm not trying to do that. All right, almost done, guys. We barely just need to fix the brute forcing. And I forgot why it's not working. Let me see. So we got the brute force text, and it iterates through each possible key. Then we have our output text string. Then we'll decrypt using each key. So we'll iterate through each character in the text array. Then we'll have our original index. Then if the character is a space, I'll add it to our space. If the character is what happens if the character is a lowercase letter, it will do that. If the character is an uppercase letter, then the exception will just add it. Then the brute force text. What loop is this? So this is this for loop. So once it iterates through that for loop of decrypting it, then it'll say shift of this, output text, let's equals this. Then it will go back up and try this, and the output text will be reset. So why is it doing that? Yeah, why is it just printing out the... So when we do a brute force, we're just doing the c.brute force. It'll go to the brute force. Dude, this is like a couple hundred lines. I'm trying to finish this in 10 minutes now. That's going to be the 3-hour mark. So I had 10 minutes to get this working. All right, 10 minutes. 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 10 let me see. All right, so how does this method work? This shift key. Well, we don't need the shift key, and we get the text. Oh, do we need this text to character array? Right, this text maybe? Because the text, yeah, okay. I think I forgot that. I'm surprised that still worked, but you know. This text to character array. And then it's the characters lowercase. Is this the Bruteforcing part right here? Yeah. Okay. Let's save this code. We don't need our browser anymore. All right, let me see if we can run this again. So we can run this code, IFMMP exclamation point 3. Oh my gosh, dude, why is it doing that? So that's the text. If the int original index, if the character is a space, output text. I think it's with the output text maybe. So brute force test plex equals shift output text. Why is the output text? Output text plus equals this. Why is this part being so weird though? So there's gotta be a reason that it's just not doing anything with the output text. Like it should be doing the exact same thing as this decryption process right here. And we know this decryption process works. So it should mean that our, our encryption process, our brute forcing process should be working too. Because we have both parts. That's so weird though. Okay, so if we have the encryption process set up, and that works fine, the decryption process set up, that works fine. The brute forcing is the exact same as the decryption process. It's just doing it through a loop and iterating with these keys, which means I should be able just to throw in the decryption parts right here. So if character, so I'm gonna just copy this again, see if there's any changes that were made. Do I need to get in that last? Oh no, that's for this right here. Yeah, cool. So let's copy this. And we'll take this and paste it. Save. Whoops. And Control F5. So let's try running it. And let me clear the terminal. Make it a little bit bigger for you guys. There you go. So if we enter the text hello, an exclamation point, and encrypt it, the shift key of, let's say 1, it encrypts it, right? So now it's this random, quote unquote, random string of text. So now let's decrypt it with a shift key of 1, and it says hello again. So now if we try to brute force it, oh, whoops. Yeah. There you go. So input this text, let's try to brute force it, and it just prints out the text over and over again. Why is it doing that? So let me zoom out again. So it will return the brute force text. The brute force text plus equals the shift of the output text. The output text is what's outputted after each one. So there's no reason this shouldn't be working. So string brute force text. Why is it saying the output text is equal to the this.text? Because that's not true. So for character in the text to character array, I'm gonna just restart the IDE and see what the error is. Oh, whoops, I didn't mean it. Cool. So it's looking fine. Maybe there could have been an error with that. I don't know. I'm not gonna make it big for you guys because I just want to see if it's still being weird. Whoops. So I'll run it. IFMMP exclamation point. Okay. So it's still not working, which is so weird, guys. All right, I'm gonna mark the brute forcing area right here. Forcing method. I set a goal to myself that I could finish this in the next 2 minutes, 30 seconds, so I could hit it at the 3-hour mark. I don't know if I'm able to do that, but we're gonna try. We're gonna try. So our text, private string text. So this dot option equals 1. This option equals 2. Oh, you know what we could do? Have so for character. No, that wouldn't work. Never mind. I was gonna say we could have a this option equals 3 and then parse in the brute forcing process. But the brute forcing process iterates differently because it uses because where's the brute forcing process? It's like over here. So the brute forcing, it iterates through keys first, and then it iterates through each character. That's so weird. So public string translator, it does all this fancy stuff. Public brute force. Let me make sure. Cool. So it's going to return our brute force text. That's the whole goal of this, right? So our string brute force text is an empty string because we're going to be adding text onto it. Now this will iterate through each key from 1 to 26, because there's 26 possible keys in the Caesar cipher, and it will then iterate through each character in the text, and it will try to use the key to decrypt it. So int original index. So it will see if it's a lowercase letter. It will create this original index, and then it will decrypt it using that index of our character. If an uppercase character, it will make the character lowercase. Then it will get the index, decrypt, and then convert the character back into an uppercase. Otherwise, it will just add the character on. There's no errors here, dude. I don't understand. Is it the brute force? Is this in the wrong section? Let's see if I add it there and see what happens. Whoops. So let's show F5 and let's try to run this. So let's enter our text, which is IFMMP, and let's brute force. That's not right. Yeah, that's not right. So our brute force text does not go out there, but it goes out here. Actually, you know what? What happens if I copy this into my Powershell? Oh, okay, so this still works. So we can do hello. Okay, I'm gonna run the code on this Powershell so you guys can see it a lot easier. So option 1, so key 1. All right, cool. So let's try brute forcing this, dude. So if our text is IFMMP 3, all right, that's not working. Let's try just doing the text. I don't know if it's going to make much of a difference, but it's worth a shot. IFMMP 3. Nope. All right. So shifted index, original index. Oh my gosh. I found the error again. We're using the shift key when this should be a shift, because we don't use the shift key during the brute forcing process. We just use our shift variable, which is the iterated key. Oh my gosh. So if I run this, if I do IFMMP, option 3, thread main. All right, so now the so what's the error? Why did I say it like that? Oh, like that. All right, now let's IFMMP with option 3, and then option 1 is hello. Oh, we did it. We did it. We finally finished at the 3-hour 4 mark. All right, we finished. All right, let me just clean up the code. Make sure there's nothing done or nothing dumb that I need to fix. This is a long file, dude. All right. I know we can use text, but I'd rather have the this.text just to show good practice. I don't know. That's the decryption. Uses the this.option. All right. I think we're done. So let me open up the Powershell. Let me clear. So if we run our code, enter the text subscribe to Cosmodium CS. 2 exclamation points. Oh, I know what I want you to do actually before I finish it. Instead of making our new line at the end, I want one at the beginning and then one at the end. There you go. That's there. I want you to do. Yes. Terminate. Clear. All right. So if we get our subscribe to Cosmodium CS, that's my search point. Let's encrypt it with the shift key of 9. There you go. All right, so let me copy that. Okay. So now we can run this again. Input our text and decrypt it with the shift key of 9. And it stopped working again, dude. It's always this stuff, man. It's always something like that, man. Why is it doing this? That's just the decryption process. Why is it not working? This is the most 2 steps forward, 1 step back video I've ever made in my life, dude. Oh, this is the main code, yeah. All right, so let me, no, clear. All right, so if we do hello, actually, you know what? Yes. If we put this text in, whoops, I didn't mean to do that backspace. Ah, my gosh. All right, Control V. If I hit 3. Okay, it's not working again, guys. Oh my gosh, dude. Do I still have water? Did I finish all my water? I still saw it. All right, now I finished all my water. Oh my god, dude. If you guys want to see a more advanced version on this, I talked about this earlier in my stream, but I have a Python version of this I did a while back, and it's on my GitHub. Link is in the description and stuff. Okay. Sorry, guys. I am just brain dead right now. So, um, let me see. Okay, it's obviously something wrong with the decryption process. This is the brute forcing. So, because the encryption process works fine. All right, it's time to do some testing. Cool. So if we do hello and encrypt it, shift key of 1, IFMMP, that's right. So if we try this again, and IFMMP, the shift key of 2, with option decrypt, shift key of 1, it says hello. And enter the text, IFMMP, and choose a brute force option. Option 1 will be hello. So that works fine. The code works. So let's try it again. But this time we'll do a capital hello. And encrypt with a shift key of 1. The I is capital, the rest is lowercase. Cool. So now if we do enter text, capital IFMMP, and choose to decrypt it with the shift key of 1, it will be a capital hello. Awesome. So if we clear that, let's try this again. So this time we're going to do hello with an exclamation point, encrypt it with a shift key of 1. That's perfectly right. Now if we do IFMMP exclamation point and decrypt it, shift key of 1, that's hello. Perfect. So the last thing we're going to do is check for spaces. So if we do hello space Bob, encrypt, shift key of 1, that looks right. So if I do capital IFMMP CPC and decrypt with a shift key of 1, it's hello Bob, which means the brute force is going to work, right? Capital IFMMP CPC and option 3, shift key of 1 is hello Bob. So if I do hello world exclamation point, encrypt it, shift key of 1, yeah, that looks right. So if I do this and decrypt it, shift key of 1, it's hello world. And if I brute force it, 3, hello world. Okay, the code works. I guess it was just tripping up or something, but the code works. So we're done. The code will be on my GitHub if you guys want to check it out. Let me go on my face. All right, but that's it, guys. I hope you guys enjoyed today's live stream. I haven't live streamed in a little bit, so I thought I'd come back here today and do some cool cryptography with Java. Hopefully it was semi-educational, semi-entertaining. But yeah, that's it. So I will see you guys in the next one. So stay happy, stay positive, and as always, happy hacking, y'all.